current scientific story, the origin of the universe, begins with an explosion which made space itself expand. About 15 billion years ago, all the matter and energy that today make up the observable universe were concentrated into a space smaller than the head of a pin. The cosmos blew apart in one inconceivably colossal explosion, the Big Bang. And the stuff of the universe, together with the fabric of space itself, began expanding in all directions as they do today. The early cosmos was everywhere white hot. But as time passed, the radiation expanded and cooled, and in ordinary visible light, space became dark as it is today. But then little pockets of gas began to grow. Tendrils of gossamer clouds formed, colonies of great, lumbering, slowly spinning things, steadily brightening, each a kind of beast composed of 100 billion shining points. The largest recognizable structures in the universe had formed. We see them today. We ourselves inhabit some lost corner of one. We call them the galaxies. We inhabit a universe of galaxies. There are unstructured blobs, the irregular galaxies, globular or elliptical galaxies, and the graceful blue arms of spiral galaxies. We've been investigating the galaxies, their origins, evolution, and motions for less than a century. These studies extend our understanding to the farthest reaches of the universe. We see that space and time are intertwined. We cannot look out into space without looking into time. The speed of light is very fast, but space is very empty, and the stars very far apart. In fact, the distances that we've been talking about up to now are very small by the usual astronomical standards. In fact, the distance from the Earth to the center of the Milky Way galaxy is 30,000 light years. From our galaxy to the nearest spiral galaxy like our own, called M31, and which is also within, that means behind, the constellation Andromeda, is 2 million light years. When the light we see today from M31 left on its journey for Earth, there were no human beings on the Earth, although our ancestors were nicely evolving and very rapidly to our present form. There are much greater distances in astronomy. The distance from the Earth to the most distant quasars is 8 or 10 billion light years. We see them as they were before the Earth itself accumulated, before the Milky Way galaxy was formed. The fastest space vehicle ever launched by the human species are the Voyager spacecraft. They are traveling so fast that it's only 10,000 times slower than the speed of light. This is the point of embarkation for all our cosmic journeys, the cerebral cortex, where matter is transformed into consciousness. Here, comprising more than 2/3 of the brain mass, is the realm both of intuition and of critical analysis. It's here that we have ideas and inspirations, here that we read and write, here that we do mathematics and music. The cortex regulates our conscious lives. It is the distinction of our species, the seat of our humanity. Art and science live here. Civilization is a product of the cerebral cortex. Kind of exploratory ventures we're talking about seem to me to be precisely the kind that are needed to reestablish a cosmic context for mankind. By finding out what the other planets are like, by finding out whether there are civilizations on planets of other stars, we reestablish a meaningful context for ourselves. Atoms are very small. 100 million of them end to end would be about so big. And the nucleus is 100,000 times smaller still. Nevertheless, most of the mass in an atom is in the nucleus. The electrons are, by comparison, just bits of moving fluff. Atoms are mainly empty space. Matter is composed chiefly of nothing. When we consider cutting this apple pie, but down beyond a single atom, we confront an infinity of the very small. And when we look up at the night sky, we confront an infinity of the very large. I imagine the Anasazi people gathered in these pews every June 21st, dressed with feathers and turquoise to celebrate the power of the sun. These upper niches, there are 28 of them, may represent the number of days for the moon to reappear in the same constellation. These people paid a lot of attention to the sun and the moon and the stars. And other devices based on somewhat similar designs can be found in Angkor Wat in Cambodia, Stonehenge in England, Abu Simbel in Egypt, Chichen Itza in Mexico, and in the Great Plains of North America. Now, why did people all over the world go to such great trouble to teach themselves astronomy? It was literally a matter of life and death to be able to predict the seasons. We hunted antelope or buffalo whose migrations ebbed and flowed with the seasons. Fruits and nuts were ready to be picked in some times and not in others. When we invented agriculture, we had to take care and sow our seeds and harvest our crops at just the right season. Annual meetings of far-flung nomadic peoples were set for prescribed times. Now, some alleged calendrical devices might be due to chance. For example, the accidental alignment of a window and a niche. But there are other devices, wonderfully different. Today, only the dry ruins of the great Anasazi cities have survived the ravages of time. Not far from these ancient cities, in an almost inaccessible location, there is another solstice marker, this one of singular and unmistakable purpose. The deliberate arrangement of 3 great stone slabs allows a sliver of sunlight to pierce the heart of a carved spiral, only at noon on the longest day of the year. The wind whips through the canyons here in the American Southwest, and there's no one to hear it but us. A reminder of the 40,000 generations of thinking men and women who preceded us, about whom we know next to nothing, upon whom our society is based. Then in the year 1877, a new telescope was completed outside of Washington, D.C. at the United States Naval Observatory. And the astronomer Asaph Hall decided it would be a nice thing to go out and discover the 2 moons that everyone knew existed, but unfortunately no one had yet seen. So he went out and looked, couldn't see anything, looked again, couldn't see anything, came home discouraged, and told his wife that this was foolhardy and he was giving up the search for the moons of Mars. His wife told him that she would hear no such thing, and he was to go right back to that telescope and find those moons of Mars. And he dutifully marched off to the telescope, and that very night found the first of the 2 moons of Mars. He called the 2 moons Phobos and Deimos, after the 2 horses which pulled
the chariot of Mars, the god of war, in Roman and Greek mythology. The discovery of these two moons, first Phobos and then Deimos, was announced. It was thought to be important. Here is a reproduction of a page of the London Times for Tuesday, September 4th, 1877. And there, beneath a large map on the progress of the Bulgarian War, is a small article sent by telegraph on the satellites of Mars, saying that the observations that were made in Washington had been confirmed at the Paris Observatory, making them reliable. There are stars which are billions of years older than our sun. Some of them very likely have planets, and therefore I can imagine civilizations immensely beyond the capabilities of our own. What capabilities those are, no one can tell, in the same sense that even the most fantastic prognostications from the middle of the 19th century about the technology of the 20th century all fell short. People like Jules Verne, asked to imagine what transportation devices people would have in 1950, imagined a kind of Victorian living room with plush velvet furniture in a gondola at the bottom of an enormous balloon which went from New York to San Francisco in only a few weeks. And he was, of course, the most imaginative speculative thinker of the 19th century. Others would have been more cautious. So it's very difficult to predict far into the future, even 100 years, when not only new technology, but new scientific principles may be discovered. Surrounding the R complex is the limbic system, or mammal brain. It evolved some tens of millions of years ago in ancestors who were mammals, all right, but not yet primates like monkeys or apes. It's a major source of our moods and emotions, our concern, care for the young. And then finally, on the outside of the brain, living in a kind of uneasy truce with the more primitive brains beneath, is the cerebral cortex, evolved millions of years ago in ancestors who were primates. If the world is to be understood, if we are to avoid logical paradoxes when traveling at high speeds, then there are certain rules which must be obeyed. Einstein called these rules the special theory of relativity. Light from a moving object travels at the same speed, no matter whether the object is at rest or in motion. Thou shalt not add my speed to the speed of light. Also, no material object can travel at or beyond the speed of light. There's nothing in physics that prevents you from traveling as close to the speed of light as you like. 99.9% the speed of light is just fine. But no matter how hard you try, you can never gain that last decimal point. For the world to be logically consistent, there must be a cosmic speed limit. If we lived on a planet where nothing ever changed, there wouldn't be much to do. There'd be nothing to figure out. There'd be no impetus for science. And if we lived in an unpredictable world, where things changed in random or very complex ways, we wouldn't be able to figure things out. And again, there'd be no such thing as science. We have not found life, much less intelligence, anywhere else yet. We send spacecraft to other planets to look for life. We construct large radio telescopes and listen if anyone is sending us a message lately. Both of these activities have led to occasional tantalizing data, but none of it of a sufficient quality to say that we've detected life or intelligence elsewhere. In our ignorance, the geocentrists find hope. They confuse absence of evidence with evidence of absence. You haven't found life elsewhere? There isn't any. We're the only living creatures in the universe, on this planet. You haven't found intelligence elsewhere? There isn't any elsewhere. It's only here. We are at the center of the intellectual cosmos. And while I could give you what I consider to be a strong plausibility argument why this conceit is also erroneous, it's only fair to say that nobody knows the answer to this issue. We have not found life or intelligence elsewhere. We're in the course of looking. Maybe we will find it tomorrow. Maybe it will take centuries. Maybe we will never find it. And all we have to do is keep an open mind. There's no other approach. You don't have to make up your mind in the absence of evidence. The study of the global climate, sun's influence, the comparison of the Earth with other worlds, these are subjects in their earliest stages of development. They are funded poorly and grudgingly. And meanwhile, we continue to load the Earth's atmosphere with materials about whose long-term influence we are almost entirely ignorant. There are worlds that began with as much apparent promise as Earth, but something went wrong. Knowing that worlds can die alerts us to our danger. If a visitor arrived from another world, what account would we give of our stewardship of the planet Earth? Pythagoras seems to have been the first person in the history of the world to decide that the Earth was a sphere. Perhaps he argued by analogy with the moon, the sun. Maybe he noticed the curved shadow of the Earth on the moon during a lunar eclipse. Or maybe he recognized that when ships leave Samos, their masts disappear last. Pythagoras believed that a mathematical harmony underlies all of nature. The modern tradition of mathematical argument, essential in all of science, owes much to him. And the notion that the heavenly bodies move to a kind of music of the spheres was also derived from Pythagoras. It was he who first used the word cosmos to mean a well-ordered and harmonious universe, a world amenable to human understanding. For this great idea, we are indebted to Pythagoras, but there were deep ironies and contradictions in his thoughts. Many of the Ionians believed that the underlying harmony and unity of the universe was accessible through observation and experiment, the method which dominates science today. However, Pythagoras had a very different method. He believed that the laws of nature could be deduced by pure thought. He and his followers were not basically experimentalists. They were mathematicians, and they were thoroughgoing mystics. They were fascinated by these 5 regular solids, bodies whose faces are all polygons, triangles or squares or pentagons. There can be an infinite number of polygons, but only 5 regular solids. 4 of the solids were associated with earth, fire, air, and water. The cube, for example, represented earth. These 4 elements, they thought, make up terrestrial matter. So the 5th solid, they mystically associated with the cosmos. Perhaps it was the substance of the heavens. This 5th solid was called the dodecahedron. Its faces are pentagons, 12 of them. Knowledge of the dodecahedron was considered too dangerous for the public. Ordinary people were to be kept ignorant of the dodecahedron. In love with whole numbers, the Pythagoreans believed that all things could be derived from them, certainly all other numbers. So a crisis in doctrine occurred when they discovered that the square root of 2 was irrational. That is, the square root of 2 could not be represented as the ratio of 2 whole numbers, no matter how big they were. Irrational originally meant only that you can't express a number as a ratio. But for the Pythagoreans, it came to mean something else, something threatening, a hint that their worldview might not make sense, the other meaning of irrational. Instead of wanting everyone to share and know of their discoveries, the Pythagoreans suppressed the square root of 2 and the dodecahedron. The outside world was not to know. We have previously found that the steps necessary for the origin of life seem to be very easy, requires only the most common cosmic conditions. We know that for evolution we need time, but we have a lot of time. There are stars which are twice as old as the sun. We know that the development of intelligence, the evolution of our kind of thinking on the earth, has taken a long time to come into being, but it has come into being only halfway through the history of the sun. And other things being equal, it is probably better to be smart than to be stupid. And smart means being able to deal with the environment. Since we know that the laws of nature are by and large the same throughout the universe, then beings that evolve everywhere must be funneled in some kind of intellectual sense so that they think about the universe more or less in the same way. There will be limitations, of course. To some extent, this should happen. Imagine a program of unmanned exploration of the entire solar system for the decade of the 1970s, which would examine every planet in the solar system, which would land several space vehicles on the surface of Mars. What would such a program cost? By the way, such a program we do not have because it was adjudged too costly. Such a program would cost less than the 1970 fiscal year cost overrun on the anti-ballistic missile system. So again, it strikes me that this nation has the resources to undertake such exploratory ventures, and certainly this planet has those resources. It's just a question of, do we wish to do it?
A handful of sand contains about 10,000 grains, more than the total number of stars we can see with the naked eye on a clear night. But the number of stars we can see is only the tiniest fraction of the number of stars that are. What we see at night is the merest smattering of the nearest stars, with a few more distant bright stars thrown in for good measure. Meanwhile, the cosmos is rich beyond measure. The total number of stars in the universe is larger than all the grains of sand on all the beaches, the planet Earth.
The sky calls to us. If we do not destroy ourselves, we will one day venture to the stars. There was a time when the stars seemed an impenetrable mystery. Today, we have begun to understand them. In our personal lives also, we journey from ignorance to knowledge. Our individual growth reflects the advancement of the species. The exploration of the cosmos is a voyage of self-discovery. We on Earth have just awakened to the great oceans of space and time from which we have emerged. We are the legacy of 15 billion years of cosmic evolution. We have a choice. We can enhance life and come to know the universe that made us, or we can squander our 15 billion year heritage in meaningless self-destruction. What happens in the first second of the next cosmic year depends on what we do here and now with our intelligence and our knowledge of the cosmos.